Right, this is example 4 on finding general solution of a first order differential equation. So step 1, we need to make sure it's dy by dx, which it is. So step 2, we write down what p of x is and what q of x is. So p of x is the thing that multiplies y. Okay, so the thing that multiplies y here is going to be minus 1 over x. And q of x is my expression on the right hand side, x squared plus 1. Okay, so we want to find our integrating factor. Mu of x, which is e to the power of the integral of p of x with respect to x. I like doing that at the side. That's going to become the integral of minus 1 over x with respect to x. So it's going to become minus log of x. Not going to put in the plus c there, we put it in a wee bit later. So this is going to become e to the minus log x. These can't simplify yet, okay, because I've got this minus 1 attached. So we're going to have to fly that to the top of the log expression as a power. E to the log x to the power of minus 1. My exponential and my natural log are inverses, so they simplify. So I'm going to be left with x to the negative 1, which I'm going to write as 1 over x. So that's my integrating factor. Okay, we're now going to multiply throughout. By our integrating factor. And it always goes to the form of the integrating factor times y equals the integral of the integrating factor times q of x. And q of x is x over x squared plus 1. Okay, we can just do a wee bit of tidying up here. I'm just going to write that as y over x. That's equal to the integral of these x's will simplify, and that'll leave me with 1 over x squared plus 1 with respect to x. Okay, so we now need to think about what do I have in my toolkit to solve this integral here. Okay, so notice on the denominator we have got x squared plus 1. And that's the same as x squared plus 1 squared. This is actually a standard integral that we're given in our formula list. In the formula list it says that if we've got 1 over a squared plus x squared, that is equal to 1 over a inverse tan of x over a plus c. So you need to be able to kind of look at these integrals and spot what's appropriate, when to use partial fractions, when to notice you've got an inverse trig function, when to notice that you need to use integration by parts, for example. Okay, so I noticed that we had to use this here because on the denominator I had something squared plus something squared. Okay, so what we can do is we can rewrite our right hand side as 1 over a, well the value of a, so this is like 1 squared. So this is going to become 1 over 1, which is just 1. It's going to become tan inverse of x over 1. So that's just going to become tan inverse of x plus c. Okay, we want to make y the subject, so that becomes y equals x tan inverse of whatever x is plus c x. That is our general solution. Okay, so it's all about just looking at these integrals and knowing what to do, what strategies you have in your toolkit to be able to solve these properly. Thank you very much.